Paris. All right, so surely by now you guys have heard plenty. We're going to a different schedule on Monday of next week, and we probably will be on that schedule for the remainder of the school year. Um, so classes all start at 7:30. I don't have this in our Zoom, our try again, Mr. Reader, our Google Classroom classwork tab yet, but I will put it up at the top. This bell schedule, it's in this slide, obviously, or the link to it is in this slide, but um, it'd be by grade level, 9th grade, 10th grade, 11th, and 12th grade. For the most part, they're all the same. It's just during the lunch periods, there's a little bit of difference between the different grade levels. So make sure you are aware of that. Mr. Reed's classes are still going to be Zooming at least next week. I'm not sure about beyond that right now, but I am telling you for next week, you can count on there still being Zoom classes, just not at the times we're used to. They're going to be at the times that you see on this bell schedule. So yeah. So everybody has the same fourth period time frame, 10 o'clock to 10:45. That's when we'll be getting together starting next week. Does anybody have any questions about that schedule change or anything else related to the transition that is slowly taking place here? All right. Well, have no hesitation to ask questions if you come up with any. Let me stick Desmos in our chat real quick, since Desmos is half of our life right now, and I want everybody to be getting real used to it. My plan is to keep right on using only the OST version of Desmos until we get past the OST. After that, we'll probably pull out the regular Desmos again, but I want us to know what we can and can't do with our OST version. Today, we're going to talk about finding slope given 2 points on a line. We have a 12 problem assignment, which is just a little bit longer than what I intended, because two of the problems I thought I was giving you the same type of problem we had yesterday, where they showed us a vertical line and we had to realize that it was an undefined slope and that a horizontal line is zero slope. But there are actually two more problems where we're given 2 points on the line. But I'll show you how we can do it nice and quick. So assignment isn't intended to be too long. It's just slightly longer than I thought it was going to be. All right, let's take a look then. Split my screen, get Desmos going over here, and our assignment going here. The first three or four are just you looking at this equation and figuring out whether you're graphing a vertical or horizontal line. Remember, it's going right across the axis of this letter, so across the y-axis at, in this case, -5. So that'll have to be a horizontal line. That's all you're doing is a horizontal line across the y-axis at -5. So that's what all four of these first few problems are. That one's going across the x-axis, so it's going to be a vertical line at -4. No problem. So I'm hoping you can jump through those. This is the type of problem I was talking about, where we actually, I'm not going to do these. I'll come back to them in just a little bit, but this is the type of problem I was referring to that I thought was slightly different than it actually is. And then let's take a look at 7. This is what we just learned yesterday. Just a quick reminder. It may be totally fresh on your mind and you're totally cool with it, but just to make sure it's on everybody's brain how we do this. Finding the slope of this graph line, they've identified a couple points on the line for us, but not given us their coordinates unless we just think about them. But we said yesterday, well, I just always start with the leftmost point, and we've got to figure out the change in y, known as the rise, over the change in x, known as the run. So if I just real quickly remind us of that, slope is our rise from one point to another over the run from one point to another. And I like to focus on the fact that that's the change in our y coordinates in comparison to the change in our x coordinates. So if I do that, starting on my leftmost point, I'm going to go down this far. That's 1, 2, 3 units down. And we talked yesterday about the fact that down is indicated by that negative sign. Then I have to go right. Right would be a positive number, and I'm going right 1, 2, 3, 4, 5 units. So there's the slope of that line. Hopefully, we can also say, well, yes, negative slope sounds good because as I'm going from left to right, it starts forcing me to go down. That's how I know a line's got negative slope. So I'm going to go right ahead and type my negative 3/5 answer in there. Does anybody have a question about that or about anything related to that? Then we can let Alex check our work, and Alex says you did okay, Mr. Reed. So that's just a reminder of what was going on yesterday. Let's take a look at how we're going to do the same kind of thing, but we're going to do it given 2 ordered pairs today. So let's start out just using Desmos. I've decided the easiest way to put ordered pairs in here, if you've got more than one, instead of typing the parentheses and separating with commas, just come over here and put a table in. And as soon as I put that table in, I can just type the -4 for the X and the -4 for the Y. And I don't have to deal with all the parentheses and commas and stuff. And then I can do 2 and 5. You see my -4 showed up already. Now I'm going to do my 2, 5. There it is. So now it's on the grid and I can count it. Sometimes counting isn't very convenient if the points are very far apart, but I could go right ahead and count this 1, 2, 3, 4, 5, 6, 7, 8, 9 up. So if I stick with the idea that my slope is the rise over the run or the change in Y over the change in X, I already forgot that I just determined this was a 9. So a +9 for the top number. And then when I count to the right, 1, 2, 3, 4, 5, 6, both of those will divide by 3. So I could actually reduce it. Alex will accept your answer if you don't reduce it. But if I go ahead and do this divided by 3 and divided by 3 for each one, I would have 3/2 for my slope, 3/2. Okay, so that's what we've already learned to do, but now I want to look at it using our slope formula. So the slope formula, it is the change in Y over the change in X, but the way you normally see it written in a textbook, or most math teachers are going to show it to you, is like this: Y2 minus Y1 over X2 minus X1. Those are subscripts, so those are little numbers that are down below the level that the letters are written on. And all they mean is the X and Y coordinate of the first point. So sub 1 is referring to the fact that they're from the first point. Sure, we'll do all that again. That was getting a little too sloppy from Mr. Reed. So X1, Y1, and then over here are the X and Y coordinate of our second point. So that's all the subscripts mean. Sorry, I'm just trying to make sure you guys are going to be able to read what I have written. So Y2, maybe that's a little bit better. So we're going to do the same idea. When I subtract Y2 minus Y1, what I'm really doing is taking the second point, which is the 2, 5 over here, and I'm using its Y value, which is 5. That's how high it is. And then I'm going to use the Y value of the first point. It's way down here at -4. I'm subtracting this 5, take away -4. You see, that's exactly what the formula tells me to do. Y2 take away Y1 is going to be 5, take away -4. All right. That's going to give me that same number I got before. 9. I had counted it. Now I'm using the number line and subtracting to get it. Likewise, the bottom, to find the change in X, I'm going to take the X coordinate of the second point. Its X coordinate is right here at 2, and subtract the X coordinate of the first point. Its X coordinate is a -4. So x2 take away x1 is a 2 take away -4. And from that, I'm going to get the same 6 that I counted a little earlier, which does reduce to 3/2. Okay. So I just wanted to relate the formula to what we've already done, as well as look at what's really going on the graph when we're using this formula. Does anybody have a question about it? So I'm going to put the reduced version in, but you know that you don't have to be worried about reducing the fractions in ALEKS. It's going to accept the non-reduced version. All right, we'll let Alex check us out. Alex says we did okay. Let's do one more, but we're going to do it much faster. I won't go through all that stuff again. So this is my first point, so it'll be my x1 and my y1. This is my second point, x2 and y2. When I use my slope formula that says take y2 and subtract y1 over x2, subtract x1, y2 take away y1 is a -7 take away -3. Sorry, I kind of covered that up a little bit, didn't I? -7 take away a -3 on top. On the bottom, I have a +7 take away a -9. So +7 take away a -9. Of course, we can do every last bit of that calculation with Desmos. I can type in just, I need to make sure I do it carefully and type it right. I've got that negative sign, that 7, that subtraction sign, that negative sign, and that 3 typed into Desmos, and it tells me the answer is -4. While I'm calculating, I might as well do the other part. 7 take away -9 is 16. So now I'm going to come back over here and write those two answers. The top gave us a -4. The bottom gave us a +16. Both of those I recognize will divide by 4. I can enter -4 over 16 as my answer, and I will do that, but I'm going to go ahead and also reduce it, just so I'm reminding people how we reduce things manually. So -4 divided by 4 is -1. 16 divided by 4 is +4. There's the reduced form of that slope for these 2 points. I'm putting in -4 over 16 though. Whoops. -4 over 16. Okay, Mr. Reed, you're having a little trouble today. 4. Come down here. 16. Alex, would you check that for me, please? Oh, correct. However, the fraction can be simplified. All right. Any questions there? I want to come back here to number 5 then. Get this out of our way. I'm going to click on the gear and say, delete all this stuff I've been doing. And now I'm going to go ahead and enter these 2 points in the form of a table again. So -6, 1. Your tab button is one easy way to move to the next cell in your table. -6, -6. Because their x coordinates remain the same and their y coordinates change, that means one point is above the other. They're both over here at -6, but one's higher than the other one. That's a vertical line. And what we learned yesterday is vertical lines have undefined slope. Let's calculate this slope real quick. So x1, y1, and x2, y2 means when I put them into this nice little formula, what's going to happen is that I have a -6 minus 1 on top and a -6 take away -6 on the bottom. If I'm taking away the same number, that's going to end up being a 0. So on the top, I have a -7, and on the bottom, I have a 0. Remember, I already acknowledged that this is going to be a vertical line, and vertical lines we learned have undefined slope. Remember, the marble on my vertical line will just go on forever and ever. It doesn't have, its destination is undefined. So this is an undefined slope, and we can't divide by 0 because, like, if I have $10 in my hand, that would be the top number. My $10, there's no way for me to divide it evenly among 0 people. that $10 has to go somewhere. So it's impossible to ever divide by 0. That's where this undefined idea comes from. So to enter undefined, you have to use that button right there. And now it shows that it's undefined. If I go back and clear out this table, make another table, and put in this -2, -3, 5, and -3. Now I've got 2 points with the same y value, and so they're right here at the height of -3. One's left of the other one. Therefore, I have a horizontal line. That's when the marble will go 0 places. It has a slope of 0. Here's the reason for that slope of 0. When I go to calculate this, some other stuff's in my way. Maybe I'll just move that for the moment. And that way I can go ahead and identify that this is x1, y1, and x2, y2. Subscript is just all about whether it's the first point or the second point. And now when I go to calculate it, I'm going to be doing y2 minus y1 over x2 minus x1. That's a -3, take away -3, means my 0 is going to be on top this time. The bottom is going to be 5, take away -2. I have 0 over 7. But if I start out with $0, I can divide that among my 7 friends. It just means all of us get to have $0 together. Okay, so that will be 0. And that's the mathematical calculation reason that your vertical line has an undefined slope and your horizontal line has a slope of 0. So if I go back to the previous one, 0 on the bottom, that's a no-no. Here, we can really emphasize that's a no-no, like this. You know those mean teachers with their red pens that do things like this? No, you can't have 0 on the bottom. It's undefined, all right? But 0 on the top, that's just fine. It just means the answer will be 0. So I can go ahead and put in my 0 right here and ask Alex to check out my hard work. And Alex says I did okay. Any questions there? The big deal is 0 on the bottom is undefined, 0 on the top just gives us